Hi everyone! In this lecture video, I will discuss the general chemical reactivities of alkane and will also focus on the very first reaction of alkane, which is the combustion reaction. So first, let's discuss the general chemical reactivity of alkane, or the lack of, because alkane are quite unreactive. And the reason why that alkane are unreactive is because the electrons distributions in an alkane are quite evenly distributed. Because alkane consists of carbon-carbon and carbon-hydrogen bond throughout, and all of this bond right here are non-polar. So therefore, there's no build-up of partial positive or partial negative anywhere within the molecule. And we can see this diagram right here is showing that the electrons are quite evenly distributed throughout. So therefore, it lacks in sites that can serve as nucleophile or electrophile. So there's none of this site anywhere on any of the atom in the molecule. And therefore, alkanes are unreactive. However, alkanes are basically a great source of bond energy because they have a lot of bond in them. So essentially, we can break this bond and produce in other types of bond that can give us energy. But other than that, they do not have that much interesting chemistry to them compared to the other functional group. So now, let's discuss the very first types of reaction of alkane, the combustion reaction. Now, combustions basically refer to the burning reaction. Anytime we burn something, it is a combustion reaction. And of course, in order to burn anything, we need to add oxygen. And normally, this comes from the air. And all combustion reaction would then be accompanied by the evolution of heat and lights. Just like when we burn a piece of paper, we'll be seeing lights and we'll feel the heat being produced from burning a piece of paper. And the process would always be an exothermic process. And overall, the general chemical equation of a combustion reaction is as follows. So alkane combining with O2, producing CO2 and water. And the delta H of the reaction, the sign should always be a negative value. Now, depending on the types of alkane, we have to balance this reaction correctly. And each of the combustion would then have a particular value of the delta H. For an example, here, first one, we have a unbranched alkane. So here in this case, it is octane because it has 8 carbon. So this is C8H18. That's the chemical formula of this alkane. And when we combine this with oxygen, we have to have 12.5 of oxygen. And this will then produce 8 CO2 and 9 water molecule as the product. And the delta of this reaction would then be negative 5,470 kilojoule per mole. So this would be the combustions of this alkane, this linear alkane. And that would be a chemical equation. Now, when we burn a different types of alkane, so here in this case, this is also octane as well, except it has branching on it. So the chemical formula for this is also C8H18, exactly similar to the other types of alkane, except it has branching on it. And when we do this, it will still require this much oxygen and producing this same exact amount of product. However, the delta H of this reaction, it is quite similar. It is 10 kilojoule per mole less compared to the amount of heat being produced by the previous unbranched alkane. And similarly, when we burn a different types of octane, here in this case it's also C8H18, but it has more branching on it. And we can then see that this actually produces smaller heat of combustion compared to the previous types of alkane that we have seen already. So what this is telling us is the following. This alkane right here, although a chemical formula exactly similar to the previous one, because this one is producing less heat energy, it tells us that this is more stable compared to this one, and then more stable compared to this one. And this brings us to this conclusion right here, that the more substituted the alkanes are, the more stable they will be. So in the end, primary carbon are less stable compared to secondary, and secondary are then less stable compared to tertiary and quaternary. So this is a very important point that we need to remember. And again, the more substituted the alkane, the more stable they will be.